Welcome to section 9.5, day 2, completing the square. Today we are once again going to solve quadratic equations by completing the square. Here we have a little warm-up solve the equation by completing the square. This is going over what we did yesterday. It's a reminder. First thing we need to do is find a c value we can add to both sides so we can use our square root property. The first thing we need to do is find a c value we can add to both sides to create a perfect square trinomial that we can then factor into a binomial squared so we can use the square root property. So first things we need to do is solve for c that we can add. You notice we already have this in the form we need where we have the x squared term and the x term by themselves on the left equal to a number. So we need to find our c. So our c in this case is 8 over 2 squared, which is 4 squared, which is 16. We're going to add 16 to both sides. So we have x squared plus 8x plus 16. Remember, we have to add it to both sides. We have to add 18 plus 16 on the right. We have created a perfect square trinomial, which we are going to factor into a binomial squared. Square root of the first, the square root of the last, all squared. Sign in the middle, don't forget that. And this is the same number that we find when we take half of b, is what we put in our binomial squared. And this is 34. We can then take the square root property. We have a squared term equal to 34. We can take the square root, and we get x plus 4 equals the plus or minus square root of 34. Move the 4 over by subtracting it from both sides, and we get that x is negative 4 plus or minus the square root of 34. And we get our two equations. X is negative 4 minus the square root of 34, and we have x is negative 4 plus the square root of 34. And we will, doesn't say on the top of this one, we're going to round to the nearest tenth like we did yesterday. And when we do this, and you do it on your calculator, you will find that we have, the first one is negative 9.8, and the second one is a positive 1.8. These are my two solutions using our completing the square. All right, for the next one, it gets a little more tricky when we do some of these because we end up getting fractions when we do half of b. But same process, don't get scared by the fractions. Again, we have the x squared term and the x term over on the left equal to a number. We just need to find a c value to add to both sides. So we take, our c is 5 over 2 squared. I prefer keeping them as fractions because you guys have a tendency to want to round decimals when you can't round them yet. And if we have 5 over 2 squared, we bring the squared term into both things, we get 25 fourths. This is what we're going to add to both sides. So we have x squared plus 5x plus 25 fourths equals 11 plus 25 fourths. The left side, it looks sort of strange, but it is actually a perfect square trinomial. And so if we have square root of the first, square root of the last is at half of b, which is 5 halves. The sign in the middle is positive. This is all squared. Equals 11 plus 25 over 4. Well, hopefully you recall that if we want to add those together, we need like denominators or a common denominator. And so the 11 is actually the same as 44 over 4. Multiply top and bottom of 11 by 4, we get 44 over fourths. And when you add this together, you get 69 fourths. We are then going to use our square root property. We have a squared term equal to a number, so we can use our square root property. Take the square root of both sides. And when we do this, we get x plus 5 halves equals plus or minus Remember that radical can be broken across the division bar. The square root of 69 is not a perfect square, so we have square root of 69. The square root of 4, though, is 2. So we can change it to plus or minus the square root of 69 over 2. We are then going to move our 5 halves over. So we're going to have x. We're going to subtract it off both sides. We get negative 5 halves plus or minus the square root of 69 halves. And there's a couple of ways to approach this from here. Just use your calculator, but set up your two equations. Don't forget that. We have to have a negative 5 halves minus the square root of 69 over 2. And we have to have negative 5 halves plus the square root of 69 over 2. And when you use these on your calculators, to the nearest tenth, we will get negative 6.7 and a positive 1.7. And like I said yesterday, sometimes it's going to ask you to round to the nearest tenth, sometimes it's going to ask for the nearest hundredth. And if it doesn't ask you to round on your homework, we want exact answers. Another thing that's going to happen today is all the problems we've worked with so far have had the leading coefficient of 1. The only way we can use this completing the square is if the leading coefficient is 1. So it says here, if the leading coefficient is not 1, you must divide it out before completing the square. The only way this completing the square works is if the leading coefficient is 1. So we're going to solve by completing the square, and we're going to round to the nearest hundredth on this slide. So the first thing we need to do, well, we have to do two things. For the first one, we need to get it so it's just the m squared and the m term on the left side. And we also have to get a leading coefficient of 1. So we can either move the 8 first or divide everything out by 4 first. Me, I'm going to divide everything out by 4 first. But it doesn't matter which order you do it. And you technically should be dividing 0 by 4 also. So we get m squared minus 4m plus 2 equals 0. We then need to get the m squared and the m term by themselves, so we're going to subtract 2. And we have m squared minus 4m plus some c value we're going to find equals negative 2 plus that same c value. No matter which step you did first, you should still end up with this. M squared minus 4m equals negative 2. Now we got to find our c value. I'm going to do our c value here on the top to save some space. So c is our new b, which is negative 4, divided by 2, all squared. This is negative 2 squared, which is positive 4. So we're going to add 4 to both sides. Now we have on the left a perfect square trinomial. And we take the square root of the first, square root of the last, sine of the middle. And remember that minus 2 is the same as what we had before we squared our half of b. This is all squared equal to 2. Again, we now have a squared term equal to a number. Use the square root property from 9.4 day 1. And we get m minus 2 equals plus or minus the square root of 2. We're going to move the negative 2 over by adding it to both sides. And we get m equals 2 plus or minus the square root of 2. And this becomes our two equations. This is going to be 2 minus the square root of 2. And m equals 2 plus the square root of 2. And we are going to the nearest hundredth on this slide. 2 minus the square root of 2 is 0.59. And 2 plus the square root of 2 is 3.41. So these are my two solutions. Our m's are at 0.59 and 3.41. For the one on the right, again, we need to divide it out. We can either divide by 5 first, or we can move the 125 first. I'm going to divide out. I divide everything by 5, so that leading coefficient becomes 1. Because we can only use it completing the square when the leading coefficient is 1. When we divide by 5, we get x squared plus 12x plus 25 equals 0. One of those things you might notice here is we have a perfect square at the end and a perfect square at the beginning. But this is actually not a perfect square trinomial, because if you take and try to do this, you'll find out that when you take 5 times x and double it, it doesn't equal 12. So we need to move the 25 over to the other side so we can complete our square. So this is now x squared plus 12x plus some c value equals negative 25 plus some number. We don't know yet. I'm going to do this on the top. Our c is 12 over 2 all squared. That's our b again, which is 6 squared, which is 36. We're going to add 36 to both sides. The left side is now a perfect square trinomial. We take the square root of the first, square root of the last, sine in the middle, all squared. And again, that number 6 is from our half of b. And negative 25 plus 36 is 11. We can now use our square root property. Take the square root of both sides. We get x plus 6 equals plus or minus the square root of 11. Move the 6 over, we get x is negative 6 plus or minus the square root of 11. So now we have two equations. X is negative 6 minus the square root of 11, and x is negative 6 plus the square root of 11. And when we do these and we round to the nearest hundredth, for the top we get negative 9.32. And for the other one we get negative 2.68. These are round to the nearest hundredth. Those are my two solutions. So a lot of what you're doing today is similar to yesterday, except for on some of your problems, the leading coefficient is not 1. And to complete the square, the leading coefficient must be 1. If it is not 1, we must divide the entire equation by that coefficient to make it a 1 in front of the x squared term, or our squared term. We have the senior class buys jerseys to wear to football games. The cost of the jerseys can be modeled by this equation. C equals 0.1 x squared plus 2.4 x plus 25, where C is the amount it costs to buy X number of jerseys. And they want to know how many jerseys they can purchase for $430. Since we're using 430, that is our cost. So we're going to set this back up and put 430 in for C. And I'm going to rewrite this a little bit differently to put in the form we've been using. So we have 0 and 1/10 x squared plus 2 and 4/10 x plus 25 adds up to $430. For this one, again, our leading coefficient is not 1. It's 0.1, which is a tenth. So we need to divide everything out by this 0.1 or 1/10. So we're going to divide everything out. And when this does, if you do this on your calculator, you're going to notice it's going to move all your decimal places 1. So now we have x squared plus 24x plus 250 equals 4,300. We want to solve this by completing the square since we're in section 9.5. So we have to move this 250 over because right now we do not have a perfect square trinomial on the left. We need to create one. We have x squared plus 24x plus some c value we're going to find equals 4,050 plus some c value. We need to find our c. I'm going to do this on the top. We have 24 for our b divided by 2 all squared is 12 squared, which is 144. So we add 144 to both sides. When we do this, the left side is now a perfect square trinomial. Square root of the first, square root of the last, sine in the middle, all squared. Or you can just look at that b, half of b, the second part of our binomial. We add these together, you get 4,194. We then take and use our square root property. We have a squared term equal to a number. So the square root property comes into effect, and we get x plus 12 equals plus or minus the square root of 4,194. So we're going to subtract 12 from both sides, and we get x equals negative 12 plus or minus the square root of 4194. And then we're going to solve both equations. We're going to set up. We have negative 12 minus the square root of 4194. And we have negative 12 plus the square root of 4194. And we solve both and see what we get. When we do the top one, we get negative 76.76. When we do the bottom, we get 52.76. And what happens a lot of times when we have word problems is one of the answers makes no sense at all. The top answer in this case at negative 76 makes no sense. It's saying we can buy negative 76 jerseys. Well, we don't buy negative things. So that is a nonsensical, it's called an extraneous answer. So that's an extraneous solution. The one we want is this on the bottom, the 52.76. But we can't buy partial jerseys. So the most we can buy is 52 jerseys because we can't buy part of one. So we have to round to the nearest integer by rounding down. So 52 jerseys is what we can buy for $430. All right, that is all for section 9.5 day 2. Today, it's the same thing for completing the square. The one thing that's different is make sure you have a leading coefficient that's 1. If it is not 1, divide out that leading coefficient to create a leading coefficient of 1. Make sure you divide the entire equation, both sides, and that is what's different today. Thank you for watching, and have a nice day.